Hello, my mathletes. Welcome back. We're going to do 7.3 today, which is the final lesson in our unit on linear or systems of equations. And we're going to do now looking at if I have 3 variables and 3 equations. So hopefully this is a little bit of a review, maybe at least like looks familiar. Lucky for us, the solving method is exactly the same as if it was 2, okay? So we're going to use the combined methods of elimination. So we're going to be using elimination a lot. And then what we call back substitution, right? So once I found one variable, plugging it back in to find another variable. But now we're going to be solving systems of equations with 3 variables instead of just 2. So the first example here, remember that a point is a solution in a system if it's the point where the 2 lines cross, right? So wherever the 2 lines cross, that is the solution. Now that we have 3 variables, what we actually have is a 3D system. So you can think of like 2 walls meeting at 90 degrees, right? And then also the ceiling or the floor, adding that 3D dimension. So now we have our x-axis, our y-axis, and it's a little bit hard to draw. So if this is my y-axis, right, and here's my x-axis, now I also have a z-axis that is going up and down. So now I have lines in a 3D plane. And so wherever these 3 lines all cross is the solution. So the idea of the solution is the same. It's just the point where all 3 of these lines cross in the 3D plane. So when we do it, right, our first value is x, our second value is y, and our third value is z. So we still go in numerical order. So like -1, -1, right? And then down on -4. Wow, sorry, -1, -4, and then up 5. So it's actually like up here somewhere, which is like really hard to see, right? But this is the point that we're looking at right there. And so it's hard to draw on a 2D model, but if you're interested, there's a lot of great videos on YouTube or Khan Academy that have like really great models and images that you can look at here. So the first question here is wanting to know, is -1, -4, 5 a solution? Well, remember that something is only a solution if it works for all 3 equations. So I'm going to take all 3 of my equations, and I'm going to plug in my x value, which is -1, and my y value, which is -4, and my z value, which is 5. And hopefully that equals 22, right? So if we look, I have -1 plus 8 plus 15, which does actually equal 22. So this point works in the first equation. But that's not good enough. It has to work in all 3. So we have to check all of these. So I'm going to enter my x value, which is -1, and my y value, which is -4, and my z value, which is 5. Notice the negative stays outside. That gets me -2 plus 12 minus 5, which does equal 5. So it also works in the second equation. And then in the last equation, we're going to plug in -1 for x plus -4 for y, and then +5 in for z. And so that gets me -3 minus 4 minus 25, which equals -32. So because this point works in all of these, that tells me that -1, -4, 5 is a solution. So these 3 lines in the 3D plane cross at the point -1, -4, and 5. Okay, so now we're going to look at how do I actually solve these equations to get to the solution, right? Okay, that's great. I can verify that something is a solution. How do I actually find the solution myself? Okay, so that's what we're going to look at here. Lucky for us, the only thing, and this is my personal recommendation, you just need to make sure that you're super organized here. Okay, so I like to label and number my equations so that I know what equation I'm talking about. So to me, that's helpful in staying organized. So basically, what you do is you take two different pairs of equations. So like the first and the second, and the first and the third, or the first and the second, and the second and the third, or whatever, right? And you need to eliminate this same variable from each pair. And that's really important. If I take my first and second equation and eliminate y, then I need to take whatever two the other equations I'm using and also eliminate y. It does not help us if I eliminate y the first time and then eliminate z the second time. Solve the resulting systems using addition or substitution. So just solve the remaining system and then start to back substitute once you have values in. So we're going to do, we'll probably do these first two together, or at least one of them together. Probably two together, and then we'll have the two triads. So let's look here. It says solve the system. I'm going to scroll down a little bit more so I have room. Hopefully you write smaller than I do. And I personally, like I said, I like to label my equations. So I'm going to label these 1, 2, and 3. And that just helps me stay organized personally. And then I'm going to look and I'm going to decide what variable do I want to eliminate. So I'm going to look at all my x's. Okay, so I have 2, 3, and 1. So my common number would be like a 6 maybe. Or I could do like 1 and 2 and multiply this by 3, or 1 and 3 and multiply this by -2. It's like, one, then if I look at my y's, I'm not really like super excited. But I get kind of excited when I look at my z's because here I see that 1 and 2 already eliminate. And I don't have to multiply by anything. And then 1 and 3, if I multiply this by 2, then I get 2 and -2. So it seems a little bit easier. Remember, it doesn't matter. You can choose to eliminate the y's or you can choose to eliminate the x's. But in this problem, I'm going to eliminate the z's. So what I'm going to do is I'm going to take equation 1, which is x plus 4y minus z equals 20. And then I'm going to take equation 2. So that's my first pair of equations. And the reason why I chose those is because the z's eliminate very nicely. Okay, and I'm going to add them together. So I get 4x plus 6y equals 28. And I'm going to call that equation 4. And I'm just going to hang on to that for now. Okay. Then I'm going to take I need to eliminate the z's, and I haven't used equation 3 yet. So I have to use it. I know I have to use equation 3. So then I can choose, do I want to use equation 2 or equation 1? And it doesn't matter. So I'm going to use 1, but I'm going to multiply 1 by 2 because that'll eliminate my z's again. So 2x plus 8y minus 2z equals 40. And then equation 3 is 2x minus 3y plus 2z equals -16. And so what I've done is I've multiplied equation 1 by 2 to get this guy, right? And then my z's eliminate. So I'm going to add these equations together. And so this is what I mean. If I eliminate the z's in this first pair, I have to eliminate the z's again in the second pair. So that gives me 4x plus 5y equals 24. 40 minus 16, 24. And I'm going to call that equation 5. So now if I look at equation 4 and equation 5, that's just a normal system of equations that I can solve. So I can stack those. And I'm looking and I have a 4x and a 4x. So if one of those was negative, I'd be good to go. Okay, so I'm going to take equation 4, which is 4x plus 6y equals 28. And then I'm going to take equation 5, but I'm going to multiply equation 5 times -1, right? So that gives me negative 4x minus 5y equals negative 24. And you could have multiplied equation 4 by -1 instead, and it doesn't matter. I'm going to add these together. So the 4x's now eliminate, and I get y equals 4. So I have found one variable. I have found that y is 4. Once I do that, I can start back substituting, right? So now if I know y is 4, I can find x either using equation 4 or equation 5. And again, it doesn't matter which one. You can use 4 or 5. It like literally doesn't matter. So I'm just gonna use 4. So see how kind of numbering them helps? So 4x plus 6 times y, but y is 4, equals 28. So I have 4x plus 24 equals 28. Subtract 24 and I get 4x equals 4. So x equals 1. So I found my value of x. So now I know y, I know x. Now I need to know z. The only equations that have a z in them are either equations 1, 2, or 3. So I'm going to pick one of those and plug this in. And I'm going to go with equation 1 because those numbers seem easier. So I have x, which is 1, right? So 1 plus 4 times y, which is 4, minus z equals 20. So I have, let's see, 17 minus z equals 20. Subtract 17 gives me negative z equals 3. So z is negative 3. So now I found x, I found y, I found z. So now I can write it as my solution. 1, comma, 4, comma, negative 3. So that is the point where those two lines cross. 1, 4, negative 3. So hopefully that makes sense. I use these numbers to help me stay organized. If it doesn't help you stay organized, whatever, you know. But it is like when you're showing me your work and when I'm looking at your tests or I'm looking at your homework or whatever it is, it does help me follow your work and it helps me, you know, figure out like, oh, you missed a sign or whatever. So the biggest challenge here on these guys is really just the organization of it. So let's go ahead and look at B. And we'll do B together. I'm going to switch up the colors just so we don't get confused. And I'm going to label these equations. And yeah, we'll see what we do. All right, looking at B, I have my x's. Okay, like right, I could easily do 3 and 2 and 3 and 1. My y's, again, I could do 1 and 2 or 1 and 3. Z's, it doesn't matter. Like, I mean, they're all pretty much the same. They all have a 2 and a 3 and a 1, right? In some way, shape, or form. So let's go ahead and just do the z's again. That's just because that's what I have written down. I chose to do the z's again. So let's just do it. Actually, let's mix it up. Let's do the x's. I'm going to need my calculator then. Okay, so let's do the x's. So I see that 3, if I multiply 3 by -2, it'll eliminate with 1. So let's do 1, which is 2x plus y minus 2z equals -1. And then we can do 3, but I'm going to have to multiply 3 by -2 in order to get it to eliminate. So that gets me -2x plus 4y minus 6z equals -12. I'm really going out here on an edge, you guys, because I haven't done it this way yet. So plus 4 minus 6 minus 12. Okay, so these guys eliminate. I get 5y minus 8z equals negative 13. And I'm going to call that equation 4. So I eliminated the x's. So again, in my second round, I'm going to have to eliminate the x's. So now let's do 2 and 3. So 2 is just going to stay the way it is. 3x minus 3y minus z equals 5. And then 3, in order to eliminate the x, I'm going to have to multiply by negative 3. Right? Multiply by negative 3. So I have negative 3x plus 6y minus 9z equals negative 18. The x's eliminate, and I get 3y minus 10z equals negative 13. And that's going to be my equation 5. Okay, gross. So I'm looking now. The y's, I could go fit to 15. The z's, I could go to 40. Oh, I don't want to do that. So I'm going to stick with the y's. So equation 4, I'm going to multiply this guy by negative 3. Times, right, negative 3. So that gets me negative 15y plus 8 times 3 is 24. And then it'll be a positive 13 times 3 is 39. Okay. Then for 5, I'm going to multiply 5 times, not negative 5, positive 5. And that'll get me 15y minus 50z equals 13 times 5 is negative 65. And we add. So these guys cancel. Here I am going to get negative 26z. And then 65 minus 39 is negative 26. So divide, and I get z equals 1. Perfect. Once I know z, I can take that and either plug it back into equation 4 or equation 5. I'm going to use equation 4, right? So 5y minus 8 times 1, which is just 8, equals negative 13. I'm going to add 8 to the other side. So I get 5y is equal to negative 5. So y is equal to negative 1. Now I know z and y, I need to find x. So again, we can use equation 1, 2, or 3. I kind of like 3 jumps out because it's already x, but it doesn't matter. You can use any of them. So that gives me x minus 2 times 1, sorry, negative 1, plus 3 times 1 equals 6. So I have x plus 2 plus 3 equals 6. Solve, 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 right? X plus 5 equals 6. So x equals 1. Lots of 1s on this one. So now that I've found all 3 variables, I can write the solution, which is 1, comma, negative 1, comma, 1. So that is the point where these three lines cross. All right, so hopefully that's making sense. I'm going to go ahead and clear this. And we have two U tries here. So I really do want you guys to try it. Notice here that there's no X. That's okay. It's just 0, right? So same thing here, no Y. That's okay. What I would do if there's no X, I would eliminate the X's here and find equation 4, and then use equation 1 and 4 together, because then they just have the Y and the Z. Same thing here. I would use equations 2 and 3 to eliminate the Y to find equation 4, and then I would use equation 4 and equation 1 to solve. Just a personal recommendation. You don't have to use that, but let me know. Okay, so go ahead and pause the video. I want you to try these, and then when you're ready to go over them, hit play. Hopefully you guys gave this a try here. I'm going to go ahead and start labeling. 1, 2, and 3. Okay, so again, I see that I don't have an X here. So I'm gonna try to eliminate my X's here with 2 and 3. So I'm gonna take equation 2 and I'm gonna multiply it by -2. So that gets me -2x minus 4y minus 2z equals -34. And then I'm gonna eliminate that, with equation 3. So 2x minus 3y plus 2z equals -1. Okay, and let's add. So my x's eliminate, and my y's also eliminate, which is very exciting. And so I get -7y equals -35. So I get y is equal to 5. And so I didn't even then have to use, I didn't even get an equation 4. I just found that y was 5. So if I know y is 5, I can find z by using equation 1. It makes this problem nice and quick, right? So 2 times 5 minus z equals 7, right? So 10 minus z equals 7. So negative z equals -3, so z is 3. So now I have y and z. The only thing I need is x. I'm going to go with equation 2. It seems like the easiest one to find x, but again, your choice, right? So equation 2, x plus 2 times y, so 2 times 5, plus z, which is 3, equals 17. So x plus 2 times 5 is 10, plus 3 is 13, equals 17, and so x equals 4. So that one I didn't need an equation 4 or an equation 5 because multiple things canceled, and sometimes you just get lucky like that. Okay, so I have x is 4, y is 5, z is 3. There's my point. Now, if you did it another way, you should still get the same answer. Okay, so just because if you didn't do it the way I did it, that's okay. You should still get the same answer. Things that happen quite a lot is if you mess up on like one sign, right? If you're like here, you have a +7, it'll mess you up all the way through because that would make this a -5, which would get you a different answer, right? And then, so it'll mess you up all the way through. So just make sure that you're really careful, you're really organized, and you're like double, triple checking your work as you go. Okay, let's look at D now. 1, 2, and 3. Okay, so I see that my y's are eliminated in equation 1. So I'm going to take equation 2 and equation 3 and eliminate my y's. So 2 is x plus 2y minus z equals 1. And then 3, in order to eliminate the y, I would need this to be a -2. So I have to multiply by 2. So that gives me 4x minus 2y plus 2z equals 6. So you have to multiply everything by 2. That gets me 5x, right? plus z equals 7. And there's my equation 4. So now equation 4 and equation 1 both have x's and z's, so I can just skip right to there. I'm going to go ahead and multiply equation 1. I'm going to multiply by -1. So that gets me negative x minus z equals -3. I'm going to take equation 4, which is 5x plus z equals 7. So I get 4x equals 4. So x is 1. And I'm just checking my work here. This is not the way that I originally solved it on my sheet, but it doesn't matter because I'm ending up getting the same answers, right? So x is 1. Now that I know x is 1, I'm going to plug it into equation 1 because that seems real easy, right? X is 1 plus z equals 3. So z equals 2. Nice and quick. Boom. Now I just need y, so I'm going to pick either equation 2 or equation 3. It doesn't really matter. It's 6 in one, half a dozen in the other. So let's go with equation 3, which gives me 2 times x, so 2 times 1, minus y, plus z, which is 2, equals 3. So 2 times 1 is 2, plus 2 is 4, so negative y plus 4 equals 3. Subtract your 4, negative y equals -1, so y equals 1. And then once I have all three of them, I can go x, which is 1, y, which is 1, z, which is 2. So that is the point where those two lines cross. Most of these, you guys, you should be getting whole numbers or really easy decimals like 0.25 or 0.5, something like that. So if you end up getting something like really weird, then you probably want to go through and double check that you solved it correctly and that you didn't mess up on a sign or something somewhere. All right, so the next thing we're going to look at is how do we use this in data analysis, or how do we use it, like, how do I write the system of equation if I'm given A, B, and C values, or if I'm given the points that it passes through, like here, okay? And so what we're going to do is we're going to do A together, which is, it's weird because here's A and then AB. So we're going to do all of this A and AB together, and then you guys are going to try B on your own, okay? So here we have a quadratic equation. We're looking for a quadratic equation. That means my answer is going to look like this, okay? But I know that it passes through -1, 3, 1, 1, and 2, 6. So I'm given 3 points that it passes through. So I can now write these out as an equation, right? I have an x value and a y value, so I can plug that in to here. Y is 3, so let's write the point. Here's the point, -1, 3, right? Y is 3 equals a times x squared, so a times 1 squared plus, I don't know b, but I do know that x is, sorry, -1. You know x is -1 plus c. Okay, which gets me 3 equals -1 squared is 1, so that's just a. And then b times -1 is minus b plus c. Okay, the next point here is 1, 1. 1, 1. So my y value is 1. A times x, which is 1 squared, plus b times, sorry, I'm getting ahead of myself here. B times x, which is 1, plus c. So if I simplify this equation, I get 1 equals a, or 1 squared is 1 times a is just a. Here I have plus b plus c. And then my last point is 2, 6. So my y is 6. Then I have a times 2 squared plus b times 2 plus c. So if I simplify this, I get 6 equals 4a, right? 2 squared is 4, plus 2b plus c. And then here, so these are my three equations now, right? So this is equation 1, equation 2, and equation 3. The nice thing that happens when you have problems like this is that you always get CCC. And so that's usually really easy to solve, right? Because they're all just C with no variable in front of them. And so you can just multiply one of them by -1 and it automatically cancels. So that's very helpful. Okay, so then part B says now take these three equations and solve them. So I'm going to solve for A, solve for B, solve for C. Once I have those three variables, I plug them in here and I have my equation. So I'm going to take 1 and 2 and then 1 and 3, or you can do 2 and 3. You can do whatever you want, right? So I'm going to take 1 and I'm going to multiply 1 by -1. So that gets me -3 equals -A plus B minus C. And then I'm going to take equation 2, which is 1 equals A plus B plus C. And let's add. -3 plus 1 is -2. Well, my A's cancel. That's nice. I get 2B. And then my C's also cancel. So I get -1 equals B. That's awesome. We like it when we can solve for a variable easily like that. So I already have that B is -1. Okay. So now I'm going to do like maybe 1 and 3, let's say. So again, I'm going to take equation 1 and I'm going to multiply it by -1. So that gets me -3 equals -A plus B minus C. And then I'm going to take equation 3, which is 6 equals 4A plus 2B plus C. So again, my C's automatically cancel here. So I get 3 equals 3A plus 3B. But I know what B is because I just solved it. So I can do, and I'm running out of room, but I get 3A plus 3 times -1. So that's -3. I add it to the other side. I get 6 equals 3A. So A is equal to 2. Sorry, I ran out of room. So now I know A, B, I just need to know C. Again, I can pick any of these. I kind of like equation 2 because it's real simple, right? So equation 2 is 1 equals A, which is 2, plus B, which is -1, plus C. So 1 equals 1 plus C. So I get that C is equal to 0, and that's okay. So now I'm going to plug my values into this equation, right? Y equals ax squared, so 2x squared, plus bx, well, b is -1, so minus x or minus 1x, and then plus c, but c is 0. So there is the quadratic equation that goes through all three of those points. So it's just solving, right? It's just the same thing. You're just finding your values for A, B, and C. And then once you have those, you're just plugging it into the equation. Okay, so last problem here. I want you guys to try it on your own. So go ahead and, when you're ready, you can hit pause and keep going. We have 3 points that it goes through, and so you're just going to do the exact same thing. Hit pause, give it a try, and then let's hit play and go over it. All right, guys, so hopefully you gave this a shot. So here, for equation 1, we should have gotten 4 equals 1 squared is 1, so that's A, and then plus B plus C, because x was 1. For equation 2, my y is 1, my x is 2, so that would give me 4A plus 2B plus C. And then equation 3, my y is 4 again, and my x goes through 3, my x is 3, so that's 9a plus 3b plus c. So hopefully those are the equations that we got. And again, notice it's awesome because I always get this c, c, c. So it should be really easy to pick which variable to eliminate. We can just eliminate c every time, right? So let's just do 1 and 2. I'm going to multiply 1 by -1. So it gets me -4 equals -a minus b minus c. And then let's just do 2. Again, you can do any combination. You could have done 2 and 1 and 2 and 3 or whatever, right? It doesn't matter. So 1, and then I have 4a plus 2b plus c. So let's add. I get -3 equals 3a plus b. And I'm going to call that equation 4 because it didn't help me solve. I still have 2 variables, and that's okay. Then let's just do 1 and 4, or 1 and 3 again. So I'm going to do 1, and again, I'm going to multiply by -1. So -4 equals -a minus b minus c. And then I haven't used 3 yet, so I have to use 3. I get 4 equals 9a plus 3b plus c. Okay, and we add, and I get 0, and that's okay, equals 8a plus 2b. And that's equation 5. Awesome. It's okay that it's equal to 0. It's no big deal. Okay, now I'm looking, and do I want to eliminate my a's or my b's? And I kind of want to eliminate my b's because here's a 2b and here's 1. So all I would have to do is multiply by -2. So I'm going to take equation 4, and I'm going to multiply by -2. So that gets me 6 equals -6a minus 2b. And then I'm going to take equation 5, which is 0, equals 8a plus 2b. Let's add, and I get 6 equals 2a. So 3 equals a. Awesome. So once I have that one variable, I'm going to take that and I'm going to plug it back into either equation 3 or equation 4. And it doesn't matter. I'm going to use equation 4. So -3 equals 3 times 3 plus b. So -3 equals 9 plus b. Subtract, and I get -12 equals b. So now I have b. And then the last thing I need is c. And I really like equation 1 to find c, just because it's super easy, right? So 4 equals a, which is 3, plus b, which is -12, plus c. So 4 is equal to 3 minus 12 is -9, plus c, add 9, and I get 13 equals c. So once I have a, b, and c, I just plug it into the equation. So y equals ax squared. Well, a is 3, so 3x squared, plus bx, and b is -12, so -12x, plus c, and c is 13. And so that is the equation of the parabola of the quadratic function that goes through those 4 points. Sweet. Hopefully that's making sense, just over and over and over, same thing, right? If you have any questions, make sure you reach out. Otherwise, that's it for Unit 7, and I'll see you guys very, very soon.